In this episode of Stemiverse, Markus and I talk with Pasi Suhonen. Pasi is a maker from Finland. By day, he's a customer-facing engineer at Rohde Schwarz Finland, a German telecommunications company based in Munich, Germany. By any other time, Pasi is a tinkerer and lifelong learner. In this conversation, Pasi tells us about his path in education and especially his experience as an apprentice, what schooling is like in Finland, and his hobbies, in particular microcontrollers, programming and radio astronomy. I think you'll find Pasi's learning experiences very interesting. This is Stemiverse, episode 3. Welcome to Stemiverse, the podcast that helps educators become awesome at teaching STEM, be it at home or in the classroom. I am Peter Dalmaris, and with my co-host Markus Schappi, our mission is to bring you the experiences of educators, students and stakeholders who strive every day to make the teaching and learning of science, technology, engineering, mathematics and art better. Hi Pasi, welcome and thank you for being our guest at Stemiverse. So in the next hour or so, me and Markus are going to shoot a lot of questions towards you in an effort to understand how you learn, your relation to STEM, science, technology, engineering and mathematics. And if there is a bit of art there, I'd like to talk about that as well. So would you like to take a couple of minutes and introduce yourself to our audience and tell us a bit about you, if you like, about the place that you're working, just to get to know a little bit about you.
Well, thank you, Peter, and thank you for inviting me for this podcast. My name is Pasi Suhonen and I live in Finland. I'm working as a technical sales engineer for international company called Rohde Schwarz. Rohde Schwarz is an international electronics group which is specialized in the fields of electronic test and measurement equipment, broadcast and media, cybersecurity, radio monitoring, radio location, and radio communications and services. Company provides products for wireless communications and broadcast and media, cybersecurity and electronics industry, as well as aerospace and defense and homeland security and critical infrastructures. The group has been developing and producing and marketing electronic products for capital goods sector since 1933. In addition to Munich headquarters, there are regional headquarters in US Columbia and in Asia Singapore. Almost 6,000 of the company employees work in Germany, including around 2,000 employees at the Munich headquarters. And worldwide, the company has a total of 10,000 employees over 70 countries. It's family-owned and self-financing. Exports account for 90% of revenues. The company invests around 16% of its annual net revenue into research and development.
That's very impressive. I suppose the culture in the company is full on engineering, isn't it? Like the engineering headcount must be very high.
That is basically true. It's basically an engineering company, and almost every sales guys are holding an engineering degree from university. So we can say it's pretty much engineering company, and really old generation. Back in 1933, these guys were developing and started the company from the garage, and now it's over 10,000 people worldwide, and we have subsidiaries over 70 countries. It's been really great to work with this company.
Is the family continuing, like the family that started the company, continuing to own it now through its descendants?
Yes, they are involved in the board of executives, and they are still around. These families, Rohde and Schwarz, they were doctors back in 1930s, and I think their grandchildren are now running also the company. So it's really old traditions.
So can I assume as well that the board of executives are mostly engineers instead of, I suppose, lawyers and accountants like in other organizations?
Yeah, I would say most of these guys are engineers, yes. Yes, that's true.
This is a terrible question, but I want to know how the company survived the war and then ramped up after the war.
Yeah.
Because that one must be an interesting story.
Yes, I don't really know about much of that period of time. All I know that we were producing some products for electronics back then, but that's something I really do not know. I have seen one schematic from the signal generator which was produced in 1942. And
wow, yeah, middle of the war.
yeah, that was running with tubes, and I think they can still manufacture it if they can find proper parts, and the schematics still exist.
Yeah, those were the days.
Yes.
Amazing to have such a, an engineering company with such history.
Yes.
There's not too many like that in the world. So.
Is it common in Germany for family-owned companies to grow that large without privatizing and going into the stock market and all that?
Yes, I think so. That's quite common because most of our company, which we are working also as partners, many of these are family-owned companies. I think the Germans would like to keep it that way because there are certain risks to go into the stock and grow out of your league. So it's really rough out there, and I think they can handle the company more easily when everything is in your own hands. I would say like that.
It's quite common if you think about like a Swiss Army knife or a lot of the pharmaceutical companies, or like when I said Swiss Army knife, I mean Victorinox and companies like that. They're all privately owned and within the same family for generations, which is again quite different to the Western side of things.
We're not used to that. In Australia, obviously, when a company reaches 5,000 employees, it's sort of time to go to the stock market now and sell.
Yes, that is really common, and I think it creates a lot of pressure from the stockholders towards the company to make a good profit, and otherwise they are really hasty to do certain things if everything is not going well. So I prefer family-owned. That's my.
Definitely, the culture is so much different. Let's switch from the company, and I'd like to interrogate you and ask you about your training, because from a few moments that we spent talking earlier before we started recording, you mentioned that your training goes back to I think 1989 when you graduated. Can you tell us about what training in engineering or in your discipline was like back then? That predates me and Marcus as well.
So my training is basically an ongoing process. It started when I graduated from the vocational school back in 1989 with a degree of radio and TV mechanic. And back then we were working with analog equipment, and everything was analog. TV was analog receiver and there were analog transmitters, so that was a complete different domain to work with and repair these TV sets, because we had to do repairs on the component level. Between 1989 and present day, I have studied and graduated from 4 different study programs. And during the 10 years of time while I was practicing my profession as a radio and TV mechanic, I graduated from 3 different apprenticeship contract study programs, which covered areas of telecommunication technology, computer technology, and supervisor for electrical safety.
How did they work? What was that process?
The process is that you have to find a company who is willing to take this apprentice to work, and basically you are going. It's normal work. But there is also school involved, and you get official certificate for graduating this program. You will go to work and learn practical things directly to the company which you are working for. And then you have theoretical studies which you have to attend in a school in order to get the certificate. And I think it's really cool aspect to think if you want to work and study at the same time, because you get the specific training for a specific job and you get certified at the same time. And for me, that was really good experience. I did it 4 times with these companies, and these apprenticeship contracts, they normally last 1 to 3 years, depending on the program.
Mm-hmm. Is it typical for, I suppose, vocational style education to become an apprentice and have a mentor to guide you through, as opposed to a university where things happen more in the classroom, I suppose, kind of disconnected from the rest of the world?
Yes. One of the challenges with this apprenticeship programs is that you have to find a good person from the company who is willing to guide you through with the work processes. And basically, with these programs, you get education in schools. So the most challenge is within the working place to find a person who is willing to teach you from the scratch to an expert level. So that's one of the challenges. But these things are usually working well if the company is willing to do this kind of program.
And how did you go about finding somebody to mentor and teach you within these companies?
Basically, you have to make a contract with the company, and there you have certain statements that somebody is really doing it. It's written on the paper, and it's also mandatory for the school. They want to know that this company is really willing to do these kind of things, and they are committed to teach the student in a proper way. And if it is not done, the contract is it's not valid anymore.
Okay, and this is mostly driven from the educational institution?
Yes, it's a formal. It's a formal educational program, but it's a different way to learn and work at the same time.
Okay, cool.
I'd like to explore your apprenticeship a bit more, if that's okay. Because I haven't had an experience like that, so I went through university and I had to sit in a classroom, listen, read, and go to an exam. And I never really, until I graduated, I didn't really know what engineering is like in the field, which is, I suppose, different to your experience. Could you describe like a typical day with your mentor? What was that like?
Yes, back then I was working with this radio and TV set repair shop, and my typical day was that we received broken devices into the shop, and we repaired them. I was specialized on the TVs, and basically this mentor was training me to how to do the proper fault finding from the TV sets, and that was customer service basically, which we were doing. So, like I mentioned, back those days we were working with analog equipment, and we were repairing TV sets in a component level. So it takes a long time to get familiar with the logic of fault finding and when to start and how can you do it effective way. And this is where the mentor is really valuable, because he knows straight away what stage is faulty and how should you pinpoint your faulty parts and things like these. So that was basically hands-on training all the time when I was working. And these apprenticeship contracts, they didn't certify me as an engineer. For that I went to university in a separate place back in 2007. But this radio and TV mechanic thing, that was really cool to have this apprenticeship program, especially when you are young and not experienced for fault finding.
Yeah, absolutely. Because back then TVs were expensive equipment as well. Every house would have one, and
not every house even.
Yeah, some houses would have one. So you couldn't just buy another one if yours broke down. Because now it's very uncommon actually to repair equipment, isn't it? If it's within warranty, the manufacturer will just replace it with a new set and just recycle the parts. It's not worth repairing anything. So there's very few places these days where there's actually the ability or the know-how to repair a TV or a fridge or equipment like that. I suppose it's an art that is slowly, actually not slowly, fast, disappearing.
Yes, that was totally different domain, and nowadays these repair shops, they are changing modules, partially because they are all the components are now different. They are surface mounted today, so you have to have expensive equipment to dismount them. It can be done if you have proper mass of devices to repair, and you can get good income from there. But back in 1990s, I was repairing TV sets, video recorders, DVD players, radio receivers, things like this. And TV set typically costs around, I would say, 1,000 euros. That time currency. So they were very expensive, and people used to repair them, and that was good because we didn't produce so much electronic waste, and everything was repaired, and I liked that concept a lot.
Do you still repair your own equipment?
Not so much. Only some basic power supply repairs on if you have a dried out capacitors in the primary or secondary side of a power supply and things like these, but it's not really worth of repair these expensive modules, because you have to have a special equipment to this amount, these components and processors, and it requires really high sophisticated test and measurement equipment. If you think about the digital TV nowadays, you have to have a high-speed oscilloscopes, which is going up to 1 gigahertz or something like this, and this easily costs around 50,000 euros or something like that. So it's really not so easy to repair these modules, but basic things you can do as mechanical repairs, and power supplies, they haven't changed since 90s, so there's still the same switching power supplies used, and the basic laws are applied there, so they can be repaired.
Yeah, so as long as you're a bit choosy, and especially when you work with power supplies, you know what you're doing, you save. I've got the same experience. Like when one of my monitors, for example, breaks down, I have some suspicion of what might be wrong, but I know that there's no way for me to go to my local electronics store and find the part that I think is broken. It's just, it doesn't exist unless you are Dell and you can find it from your own supplier in China somewhere. So just from that point of view, it's just, even if you do that diagnosis, you can't do anything about it. Pasi, could we go back in time a little bit in your childhood? I'd like take a few minutes to explore what you were like as a child. Were you, for example, curious about what's inside devices, so that you wanted to open things up and explore inside? Did you break electronics? I just wanted to know how eventually you became the person that you are now. If you dig into your childhood and see some of these early signs.
And whilst you're there, what was school like in Finland?
Oh yes, that as well. For us, it's quite a completely different experience, obviously.
Yes, that's really nice to remember the childhood. I remember two major things which had influence in my interest of science and technology. And number one was when I was a young boy, I was very interested from the games. And back in those days, first commercial game consoles came out to consumer markets, and my parents bought me this Atari 2600 console and Nintendo Donkey Kong handheld console back in 1983. And besides of gaming, I was wondering how these magical boxes were built and how does it function. So obviously I break up the Donkey Kong, never got it back to work again, but I saw what's inside it. And that was one driver to my interest of this technology. And the second one I remember quite well is when I started my vocational school, I was 15 years old. We had during the first day we had the introduction in this school, and I saw these third grade students. They were repairing TV receivers, real repairs to the receivers, and immediately on that day I knew that I want to learn more from the electronics, and that was my sort of a driver for the electronics and how things are built.
And that happened in the school, so
yes,
your school had a lab, I suppose, or a workshop where kids or the students could go and play around with TVs and radios.
Yes, the school was constructed in a way that normal people can do. They can bring customer devices into the school, and school were repairing these devices with a really cheap price. So that was a two-way learning experience. One was customer service, how to handle customers, how to book up the working and all this, and other one was obviously this technical side, how to find faults inside the TV receivers, radio receivers, video recorders, and things like this. And I really liked that concept.
This was vocational school?
Yes.
Right. Yeah, it wasn't like a mainstream school, was it? Like a public, I suppose.
Well, what age group we should
yeah.
What's this?
How old were the kids?
Yeah, that was a vocational school, and you graduated elementary school, and then you can go to vocational school in Finland. So that was it started in the age of 15, and you have to apply to the school, and then you get accepted or not. It depends from your certificates and how well you have done in elementary school system.
Was there some kind of feeding program in elementary school? So kids that wanted to go to such a vocational school having to go through certain classes, perhaps do exams, or could anybody apply with no particular preparation?
Anybody could apply without particular preparation. If I remember right, they were looking how well you have done in mathematics and physics and languages. Those were the basic requirements, and then you get points when you are applying. And it depends how good is your exams were in elementary school. That had an influence to this selection process.
Now, has the vocational school, is that still going strong? Or has that sort of model gone to the wayside as people get more interested into, I guess, going to university rather than a vocational school?
This vocational school is still strong. And you can, in Finland, this school system is that you have to go first to the elementary school, and then you have to go for high school or vocational school. And after you finish high school or this vocational school, you can apply to universities. So that is the way it is done. And if you are certified from the vocational school, you can apply to University of Applied Sciences and get an engineering degree after that. So in total, I would say this process takes about 12 years from the young person.
Well, it's a long time, isn't it? Yeah. Are you still involved in schooling or training in one way or another? I'm not sure if you have children that perhaps are going through the system now.
Yes, I have been. I've been learning with these open university courses. Computer programming and some other interesting stuff concerning the networking technologies, Cisco CCNA courses and things like these. So these are open basically for everybody, and they are quite cheap. You have to pay around, I would say, 30 euros or something like this from the one course, and they are different. It's really cheap, and there's a different kind of processes going on with these open universities. You can apply to this sort of a career path education where you get maybe 1 year training, for example, from the network technology, and that's from the autumn time to springtime, and it costs around 300 euros in total. And you can go to the school and learn there, or learn virtually via internet. So it's basically up to you how you want to do it.
Yeah, well, let's explore that for a few more minutes. I wonder. So you've gone through your apprenticeships. Then I know that you've also you've attended university on campus. I think you graduated in 2007 or 8. And then you've also done online education. You're doing that, and it seems like you're doing it constantly. How has your experience early on in your education career helped you to be able to learn, self-direct your learning now later in your life? Do you think that your early educational experiences have helped you to be able to be an independent and lifelong learner?
Yes, I would say these apprenticeship programs was one major driver for me. When I go to university, I started with my university studies in 2007. And I graduated 2012, and I did my studies in the university same time I was working full time. So my work ended 4 p.m. I went to school from 4 p.m. to 8 p.m. sometimes 6 times a week, even in Sundays. We had these labs and all these exams, and it took me 5 years to learn it. And it was a really, really interesting process, but very hard, especially if you have a family or girlfriend or something like this. It's all the timetables is really hard to adjust together, and it takes lots of time to graduate. But I would say these apprenticeship trainings, they somehow mentally prepared me during these years for this kind of learning. And Finnish school system is really flexible. You can go to full-time studies as a day student, or you can study after work. It's up to you. There's really lots of different educational programs going on in our system at the moment.
It's mostly public, isn't it? The universities and higher education.
Yes.
It's public, so that students don't actually have to pay the thousands of dollars of fees.
Yes, for a Finnish person, this is quite cheap. I would say I paid for my engineering studies maybe 1,000 euros in total for 5 years.
Wow.
Yeah,
so that's really good.
Graduates in Australia in engineering can go up to $100,000
yes.
in accumulated debt.
It's really different system. But for the foreigners, I think these universities are charging around 10,000 in one year. So there is a difference, but still it's quite cheap to compare to some other countries like yours or the UK, yes, and US, and it's really, really expensive. So I think our system is really good in a way that you don't have this economical pressure behind how can your parents support your studies. It's all up to you what you want to do, and that's really fantastic in this system.
Yeah, no, I'm fully in support. It's the kind of system that I like. It's very reasonable as well, especially when you can take into account the value that, for example, an engineer, a doctor, I guess a scientist can produce in the course of a life for the country. It's really a good investment. Anyway, that's a political question. Are you a mentor perhaps for people that want to become engineers in your spare time, maybe, or your kids? Do you see yourself as a mentor to others?
Not really, but my son is 6 years old, so he's starting to develop an interest to different things. One of these is space and universe, and
wow, yes.
So that's something. I think he got this ignition for the space from the Star Wars, so he was really really looking for that one, and we just bought him his first optical telescope for watching the moon and the stars, and that's really what I'm looking for. But I really don't know how he will be. What is his interest at the moment? There are so many different things going on.
Yeah, kids these days have got so much opportunity, don't they? Like I've got 2 kids. Marcus has 3, and they are exposed to so many things that, and actually develop strong interests in a lot of different and diverse things, that it's hard to know early on where they might actually settle until much later in life. But as parents, I suppose we just need to give them as much opportunity to explore as we can possibly do, so that they can just explore. I remember when I was a kid growing up, there wasn't much. there wasn't much actually to engage my imagination with. So I pick a hobby like I like to build model planes. There were nothing remote controlled back then, so it was all just plastic pieces that you stuck together and you painted, and then you hang it off your ceiling and explored it for a few years. And then when I got my first screwdriver, I started opening things up. There wasn't too many things to open up, but yeah, just compare our childhood to our children's childhood, and it's just such a big contrast.
Yes, it is. And also the way of learning has been changed. My son is now going for this preschool, and they are learning alphabets, numbers, and art and gymnastics and all these things. But they are not just doing it in a classroom. Instead, they can go to field trip and learn in the nature these same things. And I think that's quite interesting way to teach and learn different things.
How is your son is 6 years old, so maybe haven't had enough time to have an opinion on this, but what is the situation with STEM education in Finland? Is there an emphasis in sciences, mathematics, engineering, and even arts, a particular emphasis in those fields?
Yes, I think the technology is driving the people, so we need basic skills in elementary schools, and basic skills for using computers, phones, tablets. They are important so you can survive from the normal day activities. And I think our school system has really well adapted these devices into a classroom learning. So almost every school has these kind of equipment, so they are studying things, of course, in a paper, but also with the virtual reality sometimes, and with these computers, so young people can get experienced in a young age for these different technical devices. And one thing which I read from the newspapers while back is that our government has decided that computer programming is quite important skill. So they have plans to implement these programming studies into mandatory part in elementary school.
Mandatory. Wow. What's the thinking behind that? Is there something special about programming? Does the government believe that there's going to be a lot of programming jobs in the future, or is there something about programming that helps people develop in a certain way that is desirable?
I think it's both. They see that there are really lots of jobs in the future for programming, but also the programming can teach you how to think things in a logical way. So that's one thing, to teach logic and how things are running background, and how you can design things in some sequences and then execute the sequence and see the final result. I think this logic is the major driver for this kind of implementation.
Yeah, I think the skills that you get by becoming a programmer can be generalized in so many different ways. Like, it's really about problem solving and then using the right tool to solve a problem that you have algorithmically, which means really you're teaching the computer, and because the computer is not a human obviously yet, you need to break down your instructions to the computer down to a very fine detail. And I think that's where a lot of people that don't have that prior experience in programming they may be good at figuring out a possible solution, but they can't break it down into its components and the details, so basically they can't implement it. The programmer has got that advantage of knowing how to use fundamental programming structures and keywords to do something specific and put all that together in a configuration that solves a problem. So yeah, I think everybody should be a programmer, right?
Totally off topic.
Yes, it's not a problem at all.
I'm great at this. I was wondering, did your proximity to Russia change the types of electronics that you were playing around with back in the day, or was this not permeable? As in
the Soviet Union?
Did the electronics not make it across?
Yes, I remember back in 80s, there were restrictions to export certain electronics to Russia, and that was technology related. And nowadays, I think there's also same kind of things going on with the microwave area and things like that. But actually, I saw the Russian equipment in my military career when I was there. Also, it's not basically a career, but in Finland you have to go for the army for a certain time. It's mandatory. So we saw some Russian equipment, and they were quite sophisticated back in those days. So obviously they had knowledge of technology back then, and I still think they are really strong in areas of electronics and cyber warfare and all these things. It's really different domain.
I was going to ask, how do the electronics differ to what?
In the philosophy of the design, perhaps.
Or to what
the architecture.
Yeah, sure.
Yeah, I would say they were not so. Basically, all the architecture was the same as in the Western world, but the device itself, sometimes it could be a little rough looking compared to commercial product in Western world, but it still works. It's really robust and really good design inside the devices. Problems back then, I think they had was a lack of computer chips and proper components.
Yeah, and the software, like from the little reading I've done on the topic, the software development was, I suppose, more restricted because the computers had less memory. In some ways, they actually had to push a lot more through software out of the hardware that they had. That's why Tetris came out of Russia.
Yeah, that's true. But I think after 90s, when the Soviet Union collapses, then it really changed, and I think there are really strong software developers in Russia nowadays as well.
Oh, yeah. Now everything is different.
Okay, sorry, I took us all off track. Bring us back on track.
Let's try and come back on track. So you are now, I know that you are playing around with Arduinos and microcontrollers. It's one of your hobbies. Is that something that is relating to your work, or is it really a hobby of yours?
It's really a hobby of mine, because my work is, I'm responsible from 3 different areas. One of these is sales of broadcasting equipment and also the technical support for the broadcasting customers. And the other one is nationwide sales for EMC test equipment. So this microcontroller thing is, that's pure hobby for me at the moment.
So when did you start with that?
I think I started maybe 2 years back. I bought these Arduino platforms and started to play around with them and watch lots of videos from the internet. And I think it's really cool concept, because you can really easily get started with these things. You don't have to upload different drivers to your computer and do a lot of work to flash your program inside the controller. So it's really good platform to start and make things happen. And I have also tried to teach this to my son, but he's not yet interested from the microcontrollers. Let's see in the future.
It's a bit too raw. Yeah. But yeah, it's the Arduino, and so the Arduino is one of the suppose both the outcomes and perhaps the causes of the maker movement, and perhaps one of the reasons of why the maker movement became so big and so quickly. Because I remember when I was doing my engineering at university, we had microcontrollers that came basically as a chip. I had to put all the circuitry around it, or perhaps it came in a prototyping board that looks nothing like the Arduino, like super complicated stuff and pins everywhere, and you need to have the appropriate, precisely appropriate power supply, and you need to connect it to a computer in a particular way and use some proprietary sophisticated software that you need to spend a whole semester learning how to upload not your sketch but your firmware into. So basically it was something that the university would use. It's not something that a hobbyist would do. Back then, I remember in the 90s now, a hobbyist would play around with perhaps an FM transmitter kit that you'd buy from your electronics store and plug it in together, connect to your cassette tape to broadcast some music to around your neighborhood, pretty much. But there was nothing as sophisticated and as simple as the Arduino. In Finland, how much technologies like the Arduino or the Raspberry Pi, or say that let's focus on the Arduino, used in schools?
I think they are starting to use these Arduinos in schools. I'm not sure about elementary schools, but when I was at the university, Arduino was not in the program back then. Then we were using the other manufacturer microcontrollers. But I think it's slowly finding its way into the universities and schools. And I saw some final thesis from the different people which they did, and those were involved in Arduino. So it's really useful for many applications. And like you say, it's really easy to set up and test things and make basic I/O things really fast happening. So that's one of the advantages of this platform for sure.
And kids don't get bored just by trying to set it up for days and days. You just open up the box, plug it in, plug in an LED, and off you go. Blinks is so exciting. That's awesome. Okay, so how about we do some rapid fire questions? So what happens with rapid fire questions is that we ask you a few very small questions, unlike all our other questions, which tend to be a bit longer. And you answer, if you want, you can answer quickly, like you can even answer with a single word if that's how you feel, or take a little bit longer. So, do you want to start, Marcus?
Sure. Who has been the most influential in shaping the way that you learn? And you're not allowed to say Peter. Oh, you can say Peter if you want.
Yeah. I think there's many people during my studies and career. These are students, fellow students, teachers, colleagues, mentors. All these people have had really good practical tips what to look for and how to do it, and that is the way I've been learning.
To your teachers.
Yeah, to your teachers and colleagues, and from the fellow students also.
I wonder if when you were a kid, was there somebody that influenced you in becoming a technology geek? Perhaps somebody on TV, somebody you read about, even a fictional character. It doesn't have to be a real character, like Dr. Spock. Yes,
exactly. Spock was the one which I was watching Star Trek back then. I still do watch Star Trek. so Spock was the one. Yeah, Spock was the one person to influence on this one, and yeah, I could say that.
Almost every engineer that I've asked, it's Spock. It's not Picard, or it's not like one of the, I suppose, managers on the
yellow or red shirts.
Yeah, no, it's always an engineer. Yeah, or somebody like Spock. Awesome. Here's another one. In your daily work or hobby, is there an app an application that you can't live without? Something that you use perhaps to keep notes, to communicate with others, to learn from anything.
So from the apps, I would say for my work, that's definitely an email. Without that, I can't do my quotations. I'm a kind of a boring guy for that one. I would say for technical side, there is lots of different applications which are related to signal generation, spectrum analysis, EMI test receivers. Working with these, they are all device-related applications. So there are so many, and there is always a certain application for certain problems. So I couldn't say there's some specific app for me. So there are many of these apps which I use.
So what is one of these engineering apps that you feel probably deserves more attention? An app that perhaps people should know about?
Commercial, I suppose.
It doesn't have to be commercial, or it should be...
Could be like a simulator. You play around with simulators in electronics, or with signal simulators, or things that people can use to learn?
I would say that we have an application notes in our company website which you can use, and in there is a program related for generating an arbitrary waveforms or things like these. There is no so special. It's always device oriented application, like in spectrum analysis or signal generation. You need a certain type of equipment, and then there is an company application which is written for generating some certain things or analyzing some signals. So I would say the best thing is to go look for from our website for different application notes, which are really good, by the way, because they've been building like in university way. So there is always a background from the technology, and then there's investigations on how can you do these measurements with our test and measurement equipment. And
there's a lot of documentation then for all these
yes.
tool applications, right? So that you can train yourself to use them.
Yeah, and basically you can use any other vendor devices. It's not mandatory to use ours, but it's written, of course, to our devices. But as a practical guide, you can use these application notes.
What advice would you give to new engineers just starting out? Any tips or tricks that they should know?
What I see in my field of business nowadays, I see there are few major big business areas coming up. These are 5G mobile technology, IoT, cybersecurity, energy effective solutions, which means green technology, and healthcare. So if you are interested from the career of engineering, these might be things to look for in the future, because I think there will be a lot of different projects and programs going on around these subjects. And everything is wireless nowadays. So basically, I recommend you get some sort of a basic training from RF technology, because that's helpful at the end.
From your experience with the 4 mentors that you had back in your young days, what are those qualities of a mentor that you appreciate the most? Like if you were a mentor yourself, you'd like to have those skills.
I would say the most important skill is that you have to be willing to teach the student, even if he is asking basic questions. Because a lot of when I remember back my studies in 80s and 90s, a lot of the people, they get annoyed when you are asking same things over and over again. So I would say you have to be persistent and be willing to go with the terms of the student and set the pace for that one.
Yeah, be patient and,
yes.
and take responsibility for your students' learning, right? I've heard that somebody else was saying, yes, it's a very good skill actually. Myself being a university lecturer for 15 years, I've found that that's the most important skill is patience. adjust to the student instead of expecting the student to adjust to you. Very interesting. Do you use a programming language?
Yes, at the moment I've been studying this C programming language, and it's related to my Arduino hobbies. So that is what I'm studying, and I'm thinking about taking studies also C++ and C# maybe in the future.
Yeah, C is coming back.
Yeah,
thanks to the Arduino.
So, yeah.
Because
the engineer's programming language, after all.
Yeah.
So I know that you do a lot of training on your own accord. Would you classify any of that as professional development from the strict sense of the word, training that applies directly to your work? Is that something that happens through your company, or do they send you out to seminars? How does it work?
Yes, we have in-house seminars and also seminars for the customers, and then we have a really good training program going on from the company side, and there is a training organization who is actually making it happen, and I think it's mandatory for young sales or technical people to apply these trainings so you can get the basic feeling about our equipment. So I think our system is quite good in that way, and these are normally happening in Germany.
So yeah, obviously the training element must be very strong in your company, since technology is changing so fast. You want your workforce to keep up with all the changes.
Are there any publicly available courses that you'd recommend others do?
I would say you can look from our company website or from the YouTube, because we do also webinars, and these are open basically for everybody. So there's lots of different webinars from our experts from the headquarters, which is covering a lot of different areas like LTE, 5G, signal generation, oscilloscopes, and lots of different things.
Can you give us, I suppose, the URL of your company's website so that we can go and learn?
We'll add it to the show notes.
Yeah.
Yes. It's www.rohde-schwarz.com. So that's the global address for the, and you can probably direct it to your country website.
All right, no problem. We'll add it to the show notes so that our listeners can look it up, and we'll connect them directly to the educational content on the company's website. Okay, well, I think we are almost finished. Just a couple of last questions just to close and wrap it up. Would you have any parting thoughts for our listeners as a learner, especially anything that you would advise our listeners to do or to don't, or to look out for?
I would say from my personal experience, I was quite old when I graduated from the university. I would say study while you are young. I graduated as an age of 42, and I went to the university while I was working full time. So it's really, really rough to get all the schedules together. Besides that, I would say keep an open mind and study lots of different things in a wide scope, because you never know where you end up working with. So every skill counts.
Yeah, excellent. Thank you very much, Pasi.
Thank you, Pasi.
There was a really nice discussion, and I wish you all the best in your technology adventures and your learning adventures. I know you never stop learning, and that's a great skill to have. And we'll check with you again, say in a while, to see. Especially, I'm interested to know how your son is developing and how his space exploration interests are going.
Yeah. Yes, that sounds good.
Great. Thank you.
Thank you, guys.
That's all for this episode. If you have any questions or suggestions, please send them to our email address, questions@stemiverse.com, and we'd be happy to answer them. Do you want us to interview someone in particular? Let us know. Visit us at stemiverse.com to get the show notes of every episode. and subscribe on iTunes by searching for the name of our podcast, Stemiverse. That is Stemiverse. Thanks for listening, and we'll see you next time.